Okay, so for this one, I want to use the limit definition of derivative. So what we want to do is show that the limit, whoops, here we go, limit as h goes to 0 of f of x plus h minus f of x over h. Okay, so that's my limit definition of derivative. So I'm going to plug in x plus h in for x here at the first thing. So I'll do 3 times x plus h squared minus 2 minus, and then I want to just do all of f of x. So the most common mistake here is forgetting these parentheses here. So that just negative sign needs to distribute through that. Okay, so we get, and then another common mistake is in the squaring of the x plus h. Remember when we do x plus h squared, that means x plus h times x plus h. So don't forget that middle term. So that'll be x squared plus xh plus xh. So that's 2xh plus h squared. So don't forget that middle term there. So I'll have 3 times x squared plus 2xh plus h squared minus 2. And I'm going to go ahead and distribute that negative sign throughout. So I get minus 3x plus 2 all over h. So, and every time I write that equal sign, I need to write that limit again. Until I take the limit, I need to keep writing it. Otherwise, that equality does not hold. So now I need to distribute that 3 through everything. So I get 3x squared plus 6xh plus 3h squared. Oh, sorry, that's supposed to be squared. Okay, so then I get minus 2 minus 3x squared plus 2. And so I can note that the 2's add to 0, and I can note that the 3x's add to 0. And so what I'm left with, and again that h is on the bottom, is the limit as h goes to 0 of 6xh plus 3h squared over h. And so what I can note here is I can't just go ahead and take the limit yet because we still have that h on the bottom, but I can note that these two terms on the top both have an h in them, so I can factor that h out. And now, finally, we have this h over h, which that divides to make 1. So we end up with the limit as h goes to 0 of 6x plus 3h. And now I no longer have that pesky h in the denominator, so I can go ahead and evaluate this by plugging in h equals 0. So we're left with 6x, which is what we were trying to prove. So we're done there. The next one, I want to compute derivatives, and I can use the power rule, it says. So if I want to find f prime of x, again, f prime of x, so I'm just going to use the power rule here. So the 4 stays put, and then I'll have 5x to the 4th. And then the derivative of a sum is the sum of the derivatives, so I could do minus, the 3 stays put, 2 times x to the 1st. So you could have written that 20x to the 4th minus 6x. For the next one, I want to find dy dx. So for this one, it's going to start by rewriting what y is equal to. So we can write that as x to the negative 3 plus x to the 1/2. And rewriting it in that way will allow us to use the power rule. So I'll have dy dx equals, and then I'll just use the power rule like I had before. Negative 3x to the negative 3 minus 1 would be negative 4 plus 1/2 x to the, when I do 1/2 minus 1, I get negative 1/2. And you can just leave it like that. On this one, I have a graph of f. So I want to find the values that make each of the following true. Okay, f of 8 minus f of a over 8 minus a. Okay, so let's go here to 8. So if I want that to be less than 0, so it could just be, so this is going to be the slope of some secant line between 8 and some other value. So really we could pick any value of A between 8 and looks like 12, something like that. Anyhow, I want to pick another value so that the slope of the secant line is going to be negative because I want it to be less than 0. So really A could be, I don't know, let's just let A be 10. It could be 10, it could be 9, it could be anything like that. So we just want the slope of that secant line to be less than 0. So yeah, so any of those values would work. On this one, I want to have the slope between B and B plus 2 to be between 0 and 1. Okay, so let's see. If I did like 2 to 4, okay, it needs to be greater than 0. So we need to go from, so if we went 4 to 6, I think that slope is too big, is it? So the slope from 4 to 6 is, yeah, that's bigger than 1. That slope is bigger than 1. So let's do like 6 to 8. Is that slope bigger than 1? Slope is slightly bigger than 1. So what if we did 7 to 9? Yeah, okay. So if we did 7 to 9, so I'm just kind of picking out ones that I think might work. So if I did the slope from 7, the slope of the secant line from 7 to 9, is that a positive slope? It looks like it is a positive slope. And is that slope less than 1? Yeah, it definitely is, because it looks like at 7 it's at like 4.8 or 4.9, something like that. And then at 9 it looks like it's closer to 5. So it definitely is a positive slope, and it definitely is less than 1. So if we let B equal 7, say, that's an answer. But like I said, there are more than one answer. So if we did like, you know, maybe 6.5, we might also get something that's positive that's less than 1 anyway. So we just need to think of this as the slope of a secant line. And the 2 there is just telling you how far apart the two x values are that you're choosing. So so we just wanted to find a secant line that had positive slope that was still less than 1. Okay, so for this one, I want to say that I want to find two values of A and B such that the slope of the secant line is less than -1. So yeah, so we could pick, so let's find some places where the slope is negative and less than 1. So here at 1, it's kind of close, the height is kind of close to 4. So hang on, let's see here. Maybe I'll go to a steeper part of the graph. So at 0, it's like 5.2. And then at 1, it's like 4. So that slope, so let's do f, oh, sorry, I'm seeing my little thing here. F of 1 minus f of 0 over 1 minus 0. Okay, so f of 1 is like 5.2-ish minus, sorry, f of 1 is like, oh, sorry, I'm about backwards. Okay, that's f of 0. F of 1 is about 4, maybe 3.9, I don't know. F of 0 is about like 5.2 over 1 minus 0. So that gives me like -1.2. So there is a slope that is negative, and it's less than -1. So we can go 0 to 1, x equals 0 to x equal 1. There's some other places where it might work, like if I did like -1 to 0, that's pretty steep too. So that one might be steep enough to be less than -1.